It's not because of the math part of it, okay? It's because of this. We are going to talk about terms, okay? Terms can be made up of a variable, multiple variables, numbers and variables, or numbers. Okay, let me give you some examples of what terms can look like. Okay, 3x, that could be a term. Just the number 4 by itself could be a term. X, y could be a term. X squared, y squared could be a term. Just x by itself could be a term. Okay. There could be 3xy could be a term. Okay, so each one of these is an example of a term. Sometimes they will have exponents, other times they won't have exponents. Okay, they don't have to have exponents to be a term, but they can have exponents to be a term. All right, now, when we talk about terms, we also talk about constants. Okay, a constant is a number by itself. Okay, a constant is a number by itself. So 4 would be a constant. Okay, 3x is not a constant. Why would you think that 3 times x would not be constant, Derek? Right, but why? Why would it not be constant? Okay. Yeah, that's what the definition says. But why? In other words, what does the word constant mean? No. Don't even think of math. What is the word constant? Right. Okay. Nicole? Has no exponents. Huh? No, you're thinking in math terms. Okay. Let me ask you this, and you may have a different opinion of this. Are the rules in my class always constant, or do they change? They're constant because they what? They're always the same. They don't change. Okay? So constants, when we think in math, is something that never changes. Okay? Can the value of x change? Yes. Okay? So if I'm taking 3 times something that changes, then my answer's always going to be changing, right? So it can't be constant. But if I just have the number 4 by itself, is 4 ever going to be 5? Okay? 4 is never going to be 5. It's never going to be 2. Okay? It's never going to be a million. It's always just 4. It stays the same. Okay? You know, we're fixing to go to chapel. I can think of some biblical things that are always constant, that never change. Okay? One big one is God's love. It never changes. It stays the same. Today, yesterday, and tomorrow. Okay? God's promises never change. Okay? He promises eternal life. Is that going to change? Does it change in Revelations? No. It's still the same message. Okay? So, a constant is something that doesn't change. And when I add variables, variable means that it differs. Okay, so when I add that to the mix, then it's obviously going to change. It's not going to be constant anymore. Okay, so a constant is a number by itself, and it stays the same. Okay, now the part that people have trouble with is this next part, and that is like terms. Okay, like again, I don't understand why people struggle with this, but they do. I'm just going to be honest with you. I've been doing this for a long time, 19 years, and there are always going to be people that struggle with this concept of like terms. Okay, so the easiest one I can show you or tell you is this. Can I say I have Derek and Nicole and say that I have 2 boys or 2 girls? No, obviously not. Okay, I have 1 boy, 1 girl. Okay, those 2 things there's nothing about that you can say, that I have either 2 boys or 2 girls. Can't do that. So they're not like terms. Okay, in fact, they're more different than probably anything. A boy and a girl are totally different. Okay, when they're thinking, they're, everything. All right, so they are not alike. But I could say Derek and Matt and say that I have 2 boys. Okay, 2 aliens. No, I couldn't say aliens. Okay, can't say aliens, can't say girls. It's 2 guys. So if we took all the guys in this room today, we would have how many? 4. Okay, if we took all the girls in this room, how many would we have? 7. Okay, so if I had 4 boys plus 7 girls, okay, can I put those 2 things together and say I have 11 boys or 11 girls? No, you can't. Okay, so what they're going to give you is something like this. 14t plus 15 minus 2t. And they're going to want you to tell them how I can put like things together. In this problem, what are the things that are like? What? The t's. Okay? The things that are like are those 2 things right there. This is a constant. The other 2 are not constant. Okay? Now, what defines a like term is this. A like term is a term that has the same variable raised to the same exponent. Okay. The second thing is all constants are considered like terms. Okay, because we can put constants together. I can put 4 plus 5 together. Okay, if we didn't do that, then our whole math would change. You just basically wasted 6 years of math if that wasn't to hold true even now. Okay, so now when I have a term, for example, 4x, okay, this means 4 times the variable x. And in these lessons, we're not going to know what the variable stands for. We are not going to know the value of the variable. Okay, and that is why we've got to be able to understand like terms and doing this. Now, the number, when a number is in front of a variable, okay, when a number is in front of a variable, we call that I want to make sure. Sometimes I misspell this word, and I want to make sure I don't misspell it. We call that a coefficient. I always want to put an extra E in there somewhere, but okay, we call that a coefficient. That is only when the number is being multiplied by a variable. Okay, and the same thing I said yesterday applies to the rest of your life. The number always goes in front of the variable when the two are together. Okay? In other words, x4 is not, okay, it's not it. Not going to work. Okay, now, let's have a little sidebar here and review a rule or a property. Commutative property. Okay? Commutative property only applies to addition and multiplication. Okay, I'm fixing to show you what a commutative property is. For example, let's say I had 4x plus 9 plus 3x. Okay? Commutative property says I can do this. 4x plus 3x plus 9. And that's the same problem. Commutative property says I can flip addition facts, okay, and still get the same problem. Okay? Now, as that problem sits right there, how many terms do I have in it? How many? Right. Yeah. You have 3 terms. You have 1, 2, 3. Okay? And the easiest way to tell terms, they'll be separated by addition or subtraction sign. Okay? So I could have, back to terms just for a second, I could have this 3x squared y plus 4yz minus 6abc. Okay? But there's still only 1, 2, 3 terms. Even though this one down here has multiple letters, that has multiple letters, doesn't matter. You still only have 3 terms. Are any of them the same? No, there's not. Okay? So, let's go back to our like terms. Let me give you some examples Examples of like terms. Okay? 3xy squared. A like term would be 22xy squared. Okay? My definition says the variable has to be the same. Okay? That goes with variables or variables. Okay? The coefficient, the number in front of the variables, does not have to be the same. Okay? It's the only thing you look at to see if something is alike is this right here and this right here. What's the variable and what is it raised to? Okay? So this is like terms. Because the x is raised to the first power, the y is raised to the second power in both of them. Okay? Let me give you an example of one that isn't. That is not like terms. The reason being is over here you have x squared. Over here you just have x. Right here you just have y. Over here you have y squared. Okay? On the thing. Okay, can we be a little bit more specific than the thing?
I don't get how you got 22.
How I got what? 22. How I got 20? I just made that up. I could have said 36, 4, 5. I'm just giving you an example of numbers. I wanted to change the number to show you that this and that do not have to be the same for it to be a like term. It could be any number. I could have put 1,000 xy squared. It is this first one. This is a like term. Huh? Okay. Do both of them have the same variable? A letter.
Oh, yeah.
Okay. Both of them have x and y. Do both the x and y, are they both raised to the same exponent? Then they're the same, regardless of what the number is. In other words, let me give you another example. Using that, I could have xy squared and then have 22xy squared. And that's still like terms. Okay? Because in front of every single variable, if there's not a number, there is a 1. We just don't put it. That's really 1xy squared. We just don't say that. Just like we don't put a positive sign with our numbers. This is very important that you understand this, because here's an example of a problem you will have. X plus 3x. Okay, x plus 3x. It's the second week of the 6 weeks. Huh? But last week was, or the week before Thanksgiving was first. We don't count the week we're not here. It's not an actual week of school. Well, I'm sorry. Yep. Okay, I have x and I have 3x. Okay. Let's think back to something I said the other day. If I have x plus x plus x. No. That'd be like if I had 3 plus 3 plus 3, would that be 3 to the third power? No. Okay. How many x's do I have? 3. So this is the same thing as that. Okay, these two are the same. Just like 4 plus 4 this is the same thing as 3 times 4, because I have 3 4s. Okay? So this is the same thing as 3x. Okay, so is my x here and my x here exactly the same? Yes. So these are like terms. Okay, so if I think of this, I said 3x is the same thing as x plus x plus x. So this must be the same thing as x. So realistically then, I have, let me move it down here, I have the same thing as x plus x plus x plus x. So how many x's do I have? So the answer to that would be 4x.
Is that the like variable?
Huh?
Is that the like variable, or are you like reducing it?
That's the like variables from this problem right here. This is the answer to that problem, x plus 3x. Okay? Now, one more thing. Let's go x plus 3x plus 9. Okay? What are the like terms in this problem? And 3x and 9? 3x and x. This and this are exactly the same. This is not alike. It is a constant. The only thing that the constant has in common with any others is it has to be another constant. A constant has to be a number by itself. Remember, this is a coefficient. It is not a constant anymore. Since I'm taking 3 and multiplying it by something that varies, I can't have a constant. Okay? So, these two are the same, so I can put those two things together. We've already said that x plus 3x is what? 4x plus 9. And this is where people will make their mistake. They'll put this together and say that the answer is 13x. So you're saying then that I have 4 apples and 9 oranges, and together I have 13 apples. Now, how stupid would that be? Okay, but you'll make that mistake because you won't, for some reason, you won't link these two things together. You'll get on a test and go, oh, it's 13x. No, it's not 13x here, and it's not 13x ever. This is your answer. You can't go any further because the x there, and there is no x by the 9. Okay? That'd be like saying I got 4 black backpacks and I got 9 blue backpacks, and altogether I got 13 blue backpacks. Okay? No, it ain't gonna work that way.
So like if it did have an x, if the 9 did have an x.
Yeah, then you could put the two together. Yeah.
Oh.
Okay?
That's your answer for all the thinking that you
Okay. Well, I really didn't understand.